Yay. Hi, everybody. Welcome. This is the live moon tour, and we're here at McDonald Observatory. I'm Judy Meyer. I am a member of the program staff here at the Visitor Center, and I'm also part of the K-12 team. So I talk to visitors and I talk to teachers, and I know we have some teacher friends on the in the chat tonight watching this live stream, which is very exciting. My colleague Saul Rivera is here. And Saul, do you want to say a word too about who you are and where you are?
Yeah. So hello, my name is Saul Rivera. I'm also one of the public program staff here at the Visitor Center, so help out with the guided tours and the live streams such as these. I'm also starting to get some training from Judy on some of the K-12 stuff. So it's gonna be learning more of those ropes.
Yep. And so, yeah, it's great to have Saul here. And Saul is in a dome running a telescope. I am not in a dome. I am in the space we call the studio, which is basically a room, but I have a giant view of the sun right behind me. So there's that. So what we'd like to know from you is where you are and if you can see the moon right now. We were basically on pins and needles all day. It's been very cloudy. Scheduling a live telescope viewing during monsoon season is a difficult thing and a little bit scary to do. And it's been cloudy all day, and it was cloudy all day yesterday. And we've gotten a lot of rain, so the grass is really green. And suddenly the sky cleared up, and we do currently have a live view of the moon. So we get to show you a live view of the moon, and that's very exciting. And I'm seeing people from Massachusetts and San Antonio and Austin and California, and maybe it wasn't California.
Oh, I see Michigan.
And then I saw somebody say near the moon, and I'm like, you are not near the moon. But it was one of our moderators in the chat saying there's some clouds in the sky, but they're not near the moon. I just read that wrong. Here's someone in Ohio, someone in Tacoma. Oh, that's my brother. We don't. And Houston and New Mexico, people all over the place. How wonderful to have you here from Cleveland and Michigan. Wow, people are here. This is terrifying. I mean, this is wonderful. So here's what we're going to do. We are going to talk about the moon. We're going to talk about some of the features on the moon. And I want to let you know that the chat is open. If you're watching this live, feel free to ask questions in the chat. We have some really smart moderators here tonight who really want to answer your questions. And I kind of hate to say, but they're probably smarter than we are about the moon. So we may refer to our moderators for our moon questions. We'll just have to see. There may be some that we can handle too. And oh my goodness, someone's here from Seoul. Wow, how wonderful. So anyway, ask questions in the chat. We'll try to get them answered. And let's go on. I've got some slides to share with you. And the first one tells us our names. The next one shows you our pictures. Now you can see us a little bit up close. There's Saul. He's one of the people who loves to bake, and he baked a chocolate cake for someone who clearly needs to get off that diet. And that the other picture is me. So we don't need to look at that.
Yeah, and Julie's the other baker as well.
I am the other baker, that as well. Yes, and we'll get to that. Oh, cool. Someone's here from Williams Bay, Wisconsin. So Williams Bay is our great uncle or something, because we have history there. So here's a map of Texas, and we are in far west Texas underneath that star. And so we're far from Austin and San Antonio and Dallas and all those other big towns in Texas. But here's what it would look like maybe if you flew into McDonald Observatory on a helicopter. And you can see there's two mountains, one on either side of the image. On the right, you'll see Mount Locke. Mount Locke has two white domes. Those are our two older research telescopes, the 82-inch and the 107-inch. The mountain on the left is Mount Fulks, and Mount Fulks has our biggest telescope and our largest dome, big shiny geodesic dome that houses our Hobby Eberly telescope. And we're not in either of those. We are down at the Visitor Center, and the Visitor Center is more centrally located in this image. Let's fly a little closer to the Visitor Center. Now we're looking down on the backside of the Visitor Center, and that's our telescope park. And you can see we have 3 of our own little domes, and that's where we do our evening star parties. This month, we're doing star parties on Tuesdays, Thursdays, Fridays, and Saturdays. Next month, we go back to our Tuesday, Friday, Saturday, and skip in the Thursday night programs. But Tuesdays, Thursday, Friday, and Saturday in July, and we're busy a lot. We have our outdoor amphitheater and our telescopes, and we bring more telescopes out and have a fun time looking through telescopes. But you might notice that one of those domes has an arrow pointing at it, and the arrow's pointing at it because that's where Saul is sitting. He's inside that dome right now, and it's dark in there because he's inside. And he doesn't have the lights turned on because it's a telescope dome. And I want to show you a picture of the telescopes that we're using. And I know everything looks dark and red, and that's because when we're inside the dome, we use red lights to help us preserve our dark adapted vision. And there's our telescope pointing out at a beautiful view of the Milky Way. That's obviously a different night than tonight. Tonight we have a nice kind of twilight evening sky. It's not dark like that, but it'll get there. And you might notice the little words on this slide say the technical specs for our telescope and our cameras are in the video description in YouTube. So look for them there. We're not going to spend our time talking about the technical stuff. So let's move on. Here is a beautiful view of what the moon looks like tonight. And it's not an actual live picture. This is from a wonderful website called the NASA Scientific Visualization Studio, and that allows us to get a nice view of the moon, and we can play with it and we can do things to it. So one of the things I want you to notice about the moon is that there are big, flat-looking dark areas. Big, flat-looking dark areas on the moon. And we call those flat-looking dark areas mare, or seas. And maybe you see some of those seas. I want to label some of them, and I'm really hoping this labeling scheme works. So here we go. So I just turned one of those seas blue. That's Mare Imbrium. That's the Sea of Rains. And it's half in shadow and half in light. Then we have the Sea of Serenity. And then the next one is going to be the Sea of Tranquility. And the next one is going to be the Sea of Crises. So why do we put Tranquility next to Crises? Who knows? And then the next one that I'm highlighting, maybe it won't work, is the Sea of Fertility. So those are some of the seas. There's a few more that you can see. And that whole top half of the moon has those smooth seas. And then if you look along the terminator, that's our name for the edge where the sun is rising on the moon, you can see that there are quite a lot of craters. Let's just make the seas go away. Well, the seas didn't go away. My blue dots went away. And you can see those craters, but I think we can zoom in a little bit. Oh, no. This is the back side of the moon. So the front side of the moon has all these smooth seas, and the back side of the moon doesn't have very many. It only has a couple, just a couple of seas. But the rest of them, it's very pockmarked, very cratery. So what I'd like to ask you is to type into the chat what your ideas are about why the backside of the moon would have a lot of craters and not a lot of seas, and the front side has more seas. than craters? Anybody want to type in their ideas about that? Go ahead and do that. And maybe we'll talk about that. Or maybe we'll forget to. We'll have to see. So share your ideas in the chat, and let's just move on, because I just wanted to, I think the backside of the moon is so interesting to look at, and we never get to see it, because as the moon orbits the Earth, the front side, the side that faces us, always faces us, and the moon turns around once as it orbits the Earth, so the front side always faces us as the moon goes around. So I'm seeing answers like gravitational effect of the Earth, more volcanic activity on the front side, more rocks hit the back side. I know, isn't that interesting that one side is totally different from the other? Anything that would hit the front side of the moon would have to go by the Earth? Party in the front, business in the back. That's the best answer I've seen all night. That's kind of backwards from a mullet, right? The backside gets hit by meteors.
Lots of good guesses.
Lots of good guesses. The tidal forces. And the answer is the backside has more craters. Oh, the answer is happy first quarter moon. Thank you, Deep Sky, dude. It's good that you're here. The side that faces the Earth has a thinner crust. And so it had, these seas are big impact basins that then filled in with magma long time ago. And more of that happened on this side than the other side. Now, why it has a thinner crust, that's not something that I know the answer to. The moon's far side faces space and isn't protected by the Earth. I know that sounds like that's what it ought to be, but lava flows were able to move through this thinner crust and flood the basins. Yes, James Horner, I think you got it. Yeah. All right. So we're looking at craters. Let's move on from the seas to the craters on the near side of the moon. And Ken Fountain is going with gravity. You really can't avoid going with gravity, Ken. Let's move in a little bit. And one of the things you might notice is that there are craters, and we really like looking at the craters that are right along the edge where the sun is rising on the moon, and that edge we call the terminator. And I just want to point out a set of 3 craters that are all in a row. It kind of looks like an upside down snowman. And I just did something to make all my windows disappear. An upside down snowman. Do you all see that? It's right along the terminator, and my slide disappeared. Let's go back to it. All right. So the upside down snowman is right in here. And the head of the snowman, that is a crater named RCOS. And it looks very cool. And then in the belly button of the snowman, that middle snowball is a crater named Alphonsus. And then the base of the snowman is a crater named Ptolemaeus. And one of the things you might notice about especially RCOS and Alphonsus is that those craters have a central peak. And that central peak happens because the impactor liquefies the moon, and there's a rebound effect that happens. Alphonsus was where one of the Rangers landed. Yeah, Ranger 9, I think. I sound so smart. It's because I crammed right before. Crash landed right there in Alphonsus. Why do you name craters? Oh my goodness. If you didn't name the craters, we'd have to call them by number. So the craters got named, and I think it makes it easier to identify them. And I'm sure there are craters that don't have names. Wow, what a funny question. I mean, not a funny question, a good question. All right, so let's look at this tiny little crater that's just above Ptolemaeus. It is a little bitty crater, and its name is Herschel. And it's nice and round. And one of the things about craters is that the craters on the moon formed when something impacted the moon. And we might call it a meteoroid. We might call it an asteroid, depending on the size of the impactor. So I'm just going to call it the thing that impacted the moon. And what we're going to do is we are going to make a crater. So let me switch cameras, and this takes just a little bit of doing. Got to switch my cameras. Like I said.
The suspense.
The suspense is killing you. No, it's not. And what do I have? I have on the floor at my feet a pan of flour, and I have sifted cocoa powder onto the flour. Now, this is, I just want to say, I started life as a chemist, and I have a great aversion to eating in lab. And I think it's a very good idea to never, ever, ever eat in lab. And so I would not make craters with flour and cocoa in lab. But I also hate to waste food. And so I'm using, I'm going to call this not lab. I'm going to call this the kitchen. And I'm using a clean pan, and I'm using clean flour. And usually what we do instead of dropping, what we usually do is we usually drop a rock into this. Well, I'm not going to use a rock. I'm going to use a nutmeg. So a nutmeg is like a little rock. Let me just hold it down here in front of my camera. There it is. So it's a nutmeg, and I'm going to drop it from about 1 meter above the pan. And we'll see if we can make a crater. Here we go. Ha! That was beautiful. So the impactor hit the moon, and the stuff from underneath the surface layer flew out and streamed out across the moon. Oh, this is so wonderful. And we call that ejecta. And one of the things we might notice at the edge of the crater is a little bit of a rim where lunar material piled up at the edge of the crater. And then we call this ejecta, this crater rays shooting out away from the crater. Wow, that's a great one. You know what? I'm going to make another one on the other end of the pan, okay? All right. Okay, you ready? Here we go. This one I'm going to make from even higher. Now I hope I can, here we go.
Ooh.
And so we made 2 lunar craters. And now I'm going to go make a cake. Okay, not right now. We got to still talk about the moon. I am going to switch cameras, and I think it's time for Saul to show us.
Yeah, we're going to check out some live views of the moon. But before we actually get into that, let's try to see how those craters formed in slow motion. So we actually have a clip from one of our teacher workshops of one of these craters being made in slow motion. So this one we did use a big rock. So this was not used for baking after the fact. And now we're going to see them drop it. Boom, and you can see those really nice rays just scattering about next to it. Yeah, so now you can see more in slow motion how it goes around.
It kind of made the whole moon shake when you did that.
Yeah. If only we had the video of the giant meteor that crashed into the moon in this demonstration, which ended up knocking the entire thing over.
Oh, yeah, that was fun to do with teachers. Some of them are here because they didn't get enough of that. Thank you, Saul.
Yeah.
That's wonderful.
Yeah. So I guess we're ready to show off the live view of the moon. It's gotten nice and dark. The moon looks very nice. Also, if you're wondering why I'm in black and white and Julie's in color, it's because I have an infrared camera. So if I look directly at the camera, my eyes look super creepy. But yeah, let's bring up the moon. Actually got the snowman you were showing, Judy, in view. Kind of like a little upside down snowman figure. So there we are, live view of the moon. So there we have some of the nice craters that Julie was mentioning on the left-hand side, one near the Terminator. It's a little upside-down snowman. And let's move around a bit. Let's go up to the seas. So also this is a live view, so every now and then you can see there's like some little distortions going on. That's more of the atmosphere messing with the light. There it goes. Yeah, so here are the nice, cool seas. Well, yeah, they're still cool. It's in space. Space is cold. Yeah, and as Julie was mentioning in her image, these are like darker areas. And here, the live view, you see it's also darker. Another thing to point out, there's kind of like a yellowish tinge to the moon right now. That's because we're using a color camera. So there's still some of that kind of light reflecting off, giving it this little tinge. But the moon is not, in fact, yellow. It's not made of cheese. So we're safe there. Yeah, and Julie, do you want to mention a bit more again about these seas?
No. Let's see. What about the seas? No, I like them a lot. Move down a little bit because I want to look at the Sea of Tranquility, because it is the most wonderful shape. This is the Sea of Tranquility, and it's shaped like Pac-Man.
Oh, hey, do you see little Pac-Man?
Yeah, and can somebody type into the chat what happened in the Sea of Tranquility? What's important about the Sea of Tranquility?
Let's see, they're putting it into the chat.
Something good that we like?
They're saying the Pac-Man, yeah, Apollo 11.
Yep.
So there have been lots, as you know, lots of Apollo missions to the moon and Apollo landing sites. So actually, I do have a little map taken from the NASA website and edited by BBC4 that shows the locations of these Apollo missions. So actually, we got Apollo 11 in the Sea of Tranquility. Then also, if we move on a bit upwards, we can find the location of Apollo 17. So there's Apollo 17 on the map.
Oh, okay.
And a live view of where Apollo 17 is located on the little cusp.
Yeah, right in there.
Yeah.
Those seas do have funny names. Yep, they do.
Let's see. Oh, some question came in. Why aren't there any craters on the right? So there are craters on both sides of the moon, just that for our right now, we can only see the first quarter of the moon.
Well, do we mean on the right-hand side of this view? Because it could be that the sun is coming in from the right in our view of the telescope of the moon. And so what you're not seeing is you're not seeing shadows inside the dish of the crater like you are when you look along the Terminator. So looking right along the Terminator, we can see a lot of what do I want to say? Contrast, and we can see where the shadows and where the moon is deep, where the what do I want to say? Where the craters are deeper. Somebody, Isabel asked, why is it important to learn about craters? And one really good reason to learn about craters is that craters happen on basically all rocky planetary bodies. And so The Earth has craters, impact craters. The moon has craters. Mercury and moons of Jupiter have craters. Basically, every rocky body, Venus probably has craters. So there's craters all over the place in the solar system, and we want to know about them because they affect us as well.
Yeah.
Yeah. And John Gianforte is asking, can we put the map up again?
Yeah, so here's the map back up. So as you can see, kind of near the area we're at right now in the live view is near Apollo. Oh, meant to put the moon back up. Apollo 15.
Mhm.
And kind of as I'm pointing out some of where these Apollo missions are located, something we get asked a lot is, hey, can I see the lunar, can I see the rovers, can I see the landing sites from my telescope in my backyard, or my telescopes here on Earth? And the answer is not really. So sadly, it has to do a lot with the resolution of what your telescope can get. But okay, let's go with a bigger telescope and one in space, something like the Hubble Space Telescope. How about the Hubble Space Telescope pointed at the moon? So again, the resolution comes into question. We can't get anything that small at that distance. If we want to get some better views of things like the Apollo landing sites and such, we need something closer. So actually, the Hubble Space Telescope, the most it can make out are things about the size of a football field. That's the smallest it can make out. And none of the rovers were that big to make that out. And let's move our way a bit downwards on this view. I also saw someone was mentioning they were seeing an interesting shadow in our little upside down snowman. So something with the moon, and also something else mentioned earlier, why are the seas darker than the rest of the surface? So the seas are basically newer. It's basically as a meteor or whatever is crashing into the moon, released that lava, the underneath, it cooled down and appears darker because of that, because it's newer. As time goes on, it would become brighter as the rest of the parts are. Let's see. Oh, are most moon craters visible through home telescopes? Or are there many smaller ones?
Oh, there are many smaller ones.
Yep, there are
The big ones
craters of
are
many
visible
sizes.
through home telescopes, sure.
Yeah. So let's move around.
A fun shadow in the snowman.
Yeah, so probably what they're meaning is the way the light bounces off. So one thing about kind of the moon with it being reflective, sometimes from looking at a certain angle, it can almost look like it's a mountain instead of a crater. And another thing you might notice at the center of some of these craters, you see a little peak. So as things crash into the moon, sometimes what happens, it almost creates, as Judy kind of mentioned, almost like a little peak effect. It's almost like when you drop a drop of water into a pond, the water pushes down, it lifts up the sides, and the middle lifts up as well. Since it's magma, it kind of cools off and kind of leaves a little peak formation.
Yep. Well, I see a question from Smiling Danny that says, why do they call them seas? And they call them seas because years and years ago, before people had telescopes, they saw those dark areas on the moon and they thought maybe they were oceans. And my experience has been that in astronomy, once you've named something, you don't change it just because you know the right answer now. So we call them seas because once upon a time we thought they were seas and they're not. List the name of the seas from left to right as Judy did. It's the Sea of Rains on the left, Serenity just to the right of it, Tranquility just below it, Crises just over to the edge, and Fertility kind of below Crises and Tranquility.
There we go. Yeah, Julie knows a lot more about the moon than I do.
No, I have a map on my other screen.
Ah, okay, the good reference. So kind of going back to some of the Apollo landing sites, so something you can actually do is you can use the craters on the moon as like a reference to the landing site. So let's take Apollo 11 as an example. So it touched down near the Sea of Tranquility, near the crater of Theophilus. So we want to find that crater. We can go on up. I'm going to bring in the live view of the moon back. There we go. So as we see kind of in the middle bottom of the view, we see a very nice defined crater there. That's our crater, Theophilus, or Theophilus. It might have different pronunciations, but we can use that as reference to know where the landing was. So we know if we want to find Apollo 11, we have to move a bit northwards of that crater to the landing site. And actually above the landing site, there are 3 little bitty craters, which are actually named after the first people who walked on the moon. So we can also do that with the other craters. So kind of Apollo 12, you find Copernicus, go kind of towards the southwest of it until kind of like the edge of that view. We can't really see much of that formation right now.
No, it's in the dark right now.
Yeah. Let's see. For 14, it is
In the dark right now.
in the dark right now as well. But for that one, you look at the crater Ptolemaeus and kind of go towards its left, towards the west.
Mhm.
For 15, which I believe was visible, barely, it's near the crater of Archimedes. But Archimedes is right now itself kind of close to the shadow. But we could see.
Go back to the live view for a second, Saul. Let's see if we can find Archimedes. And go up.
To the left. While we're moving, let's see. So we can see the mountain range that was near. Actually, I think that might
There's
be
Archimedes.
Yeah, there's Archimedes.
Top of the screen.
Center that a bit.
And I think your Apollo 15 landing site is just toward Archimedes from that dark spot that's at the top of your string of mountains. There's one dark spot.
Now let's see. We can actually compare and contrast. So there we have the really nice Cavamol string of mountains. And we see it matches up.
Mm-hmm.
Yeah, let's move a bit downwards. We haven't given much love to the bottom side of the moon yet. Make our way downwards.
There's our snowman. We're just going to keep looking at him all night.
Yeah.
No.
Texas is hot. We want the cold. Well, not up here. Up here is actually pretty nice.
Yes.
Oh, actually, something we can see here is kind of the rays from the crater impacts. So as you notice, a little impact sign on the right side, it almost looks like it's kind of like expanding outwards, almost like it's opening up.
Oh, you're looking at that crater that's just over to the right, near the right-hand edge?
Yep.
Yeah, and you can see rays heading out from that, yes.
Yeah. Oh, yeah, I can bring my mouse. There it goes. This one right over here. So we can see it's kind of expanding on outwards, the rays from the impact.
I made that in my
Yeah. We were able to recreate it on our own little lab.
kitchen.
Yep, lab and kitchen and outside.
Lab and kitchen, don't get confused between the two. I like that very dark crater that all you see is darkness, but you can see a little bit on the far side.
Yeah, just it's a little bitty peak there. Yeah, let's see. I think there's one of the Apollo missions. So we already passed it.
Yeah.
But yeah, so something else that was done on the moon was that the Apollo missions, they left actually several things on the moon. So we know they left the American flag, we know they left some rovers, but they also actually left some special reflectors on the moon. So these are the locations of those reflectors. So Apollo 14, 11, and 15 left it behind. And some of the Russian missions did as well, such as Luna 17 and 21. And the reflectors look something like this image on the left-hand side. These reflectors are built in such a way that when light hits it, it goes right back to the source. Then what they did here at the McDonald Observatory, we then attached a 1,000,000,000-watt laser to our 107-inch Harlan J. Smith telescope, shot that laser at the moon, which is every scientist's dream, wait for the laser to hit the reflector, waited for it to come back, and then timed how long that took. And with that, they were able to measure how far away the moon was to an accuracy of about 4 inches. Nowadays, the accuracy is closer to about half an inch. So these were actually done on these different reflectors. It helps us find out how far away the moon actually is, that the moon has a weird wobble to its rotation, and the moon is actually moving away from us at a speed of about 1.5 inches per year. So in 5 billion years, the moon will be so far away, we will no longer have any total solar eclipses. So take advantage of the next solar eclipse coming up in April 2024. And if you want to learn more about that eclipse, you can check out our solar program from last month. We talked a bit about it. So, enjoy this view while you can. It will be very far away in the next 5 billion years.
We're not going to be around in 5 billion years, so.
Yeah, the sun will get us by then.
Yeah.
But kind of going back to some like the views and commenting earlier of, hey, we can't see the Apollo missions right now. Although no telescope of ours is really that close or that big enough to make out that view. But we have gotten pictures of the landing sites. So actually what NASA did, they sent out a satellite to orbit the moon and have 3 cameras attached to it to get pictures of the moon's surface. We call this the Lunar Reconnaissance Orbiter. So it can see, so here are pictured are the different landing sites that NASA took of the Apollo missions. So there we got Apollo 11 and 12. And what's really cool, you can see the little left behind rovers and even some of the tracks left behind, either by footprints or the rovers themselves. As you can see, some of them were let's just get us our data samples and get back. It seems like Apollo 16 had a bit more fun, like, oh, let's go this way. Ooh, let's go that way. And actually, a cool thing about the reconnaissance orbiter is it actually discovered one of the missing reflectors left behind by one of the Russian missions. It was deemed lost. We couldn't find it again. And as it was doing its orbits, the orbiter actually found it again. So then we were able to do studies on it again after kind of bringing it back up, get some new, better data. And there are lots of missions actually planned for the moon. So one that someone even asked in the chat is about something called the Artemis program. So the Artemis program is a program by NASA to send people to the moon and also send the first woman and person of color to the moon, and also establish the very first long-term base on the moon. So we can actually have people there for a good amount of time. And actually, in association with this program, there's other projects in mind, including one called the Lunar Crater Radio Telescope. Basically, it's using robots that will be sent to the far side of the moon, to then use one of the craters as basically the base for a 1 kilometer wide radio telescopes. So basically what they're doing is they have the robots in there. They're stretching this kind of wire mesh that'll be stretched all out, giving us what will be the largest radio telescope that we've made. Can't be the largest one in the world because it's no longer on the world.
And
But for
largest one in the solar system. How about that?
yeah, I like that one. The second largest one in the solar system, after this one gets made, or the current largest one, is one in China. That's about 500 meters in diameter. So also being on the far side of the moon, we don't get much noise from Earth in terms of readings, and can see very far back. They're actually hoping to get signals from what's kind of known as kind of like the Dark Age, a period a little bit after the Big Bang, and see if we can get some readings from that far back, which would be really cool. Yeah, let's see. Yeah. Yeah, and how about we answer some questions? I think there's been a lot in the chat, and thank you to our moderators for handling a lot of them. Yeah.
So while we're doing that, Saul, can you go back up to the Sea of Serenity?
Yeah.
Because Barry is asking to look at the Hamas Formation, which is the bottom side of the Sea of Serenity, I think.
They're a bit farther.
A little bit farther and up to the left.
Okay. Wrong way.
No.
Come on.
The other left.
There it goes. You know, space is confusing up, down, left, right. They all get meshed together.
Yeah. Yeah, this is the part of the moon I like looking at a whole lot because of this mountain range, and that surrounds the Sea of Rains, and so pretty. All right, so are there other questions that we can answer?
Yeah, so actually one that I kind of want to answer is one that was submitted by Fizafreen. Was a primary reason why humans didn't go back to the moon in all these decades. So one of the big reasons was there wasn't much more of a reason. One of the big reasons to go to the moon to begin with was for the space race. Once we kind of got to the moon, it was like, okay, we did what we were going to. There wasn't really much more interest in the moon. We were more interested in things farther out from that.
Well,
or
yeah, and technology kind of stopped because we were doing other priorities.
Yeah, there are lots of other projects like, oh, let's have satellites more around Earth. So it's kind of cool of getting a new interest back into the moon.
Hey, Saul, can we answer Michael Leba's question of how far were the moon satellites from the lunar surface to capture those pictures of the landing sites? Here's what I know, and I don't know the number, but here's what I know. The Lunar Reconnaissance Orbiter is in an orbit around the moon, and it was moved to a lower orbit in order to capture those images. And now it's in a higher orbit than it was. And so what they said on the NASA Science Visualization Studio said, we're never going to be that close to the moon until we go back there, because that was as close as they were going to get. But I don't know how close they got. So I asked to answer a question, and then I knew I didn't know the answer. It's kind of how I go. But it was close. And Michael, you can look it up on the NASA Scientific Visualization Studio too. Or we can look it up later and send you an email or something. Anyway.
The answer is 31 miles above the lunar surface.
Oh, Saul, you just went quiet.
Let's see.
There, that's better.
Can you hear me now?
Yep.
Oh, there it goes. Yeah, so the answer is 31 miles.
Thank you.
Let's see the Yukon's. Ooh, for this one, Wes Stanton, how steep are the features on the moon? Crater walls, mountains, etc. And are they bedrock, attached to the crust, or are they mainly piles of loose rock and dust? Do you want to answer that one, Judy?
Well, hang on. The no. Okay, so the craters that have the central peak have what we call a complex structure, and often what you see at the edges of those craters is terraces, because the impactor, the stuff flew up and then kind of fell back down around the edges, and so it's not quite as steep. And those usually have flatter bottoms. The smaller craters are more likely to have rounded bottoms. But I'm sure you don't call them bottoms. But and beyond that, I don't know. And thank you, Wes.
Yeah, so I was able to, while you were answering that portion, I was able to look up the height. So some of these can be about 10,000 feet high. Okay. There's some that are a bit taller than these and some that are a bit shorter, but they range in many sizes. And yeah, canvas, yeah, they're very, very big. Yeah. Ooh, so Joe, is the backside of the moon equally as cratered as the Earth-facing side?
Yes.
Yeah. So yeah, well they've gone through the same amount of impacts, but the actual number of craters that we see usually say more on the backside or the far side of the moon, as we like to say. So the backside has a lot more craters, while the front has a lot more seas.
Hang on a sec.
Yeah, I think Judy's going to bring up the image of it.
Yeah, I had made it go away, so I had to add it back to the stream. There's an image of the backside, and we usually call it the far side, but it is the side of the moon that faces away from the Earth, and you can see it has a lot of craters on it. But the nice thing about the moon is that something will impact it, and the crater stays where it is because the moon doesn't have an atmosphere to erode it. The only thing that will erode a crater is having another crater nearby, or an ejecta blanket from another crater cover it up or something. Where can we learn more about the backside of the moon? Oh.
Yeah, babe, for stars, where did you say you got some of these images from, Judy?
NASA Scientific Visualization Studio. Lunar Reconnaissance Orbiter took a lot of images of all the sides of the moon. Yeah, and Michael Leba's got it right that the moon revolves on its axis equal to the time it takes to rotate around the Earth. Is that unique to other moons of other planets? No, some moons are not tidally locked like that, but ours is. Yeah. I don't think it's called the far side of the moon, Teresa Anderson.
Yeah. Let's see if there's any more. I think we got time for about one or two more.
One more.
Let's just see.
Pick your favorite one. Let's take that out, put this back in.
Let me adjust the settings to make it brighter.
Oh, good.
Ooh, it got green. It's not supposed to do that. There it goes.
Oh, that's grayer. Okay.
Look back into the chat. Oh yeah, so yeah, that might be a good one. Why is it the dark side of the moon? So with the dark side of the moon, we usually call it was called the dark side because was pointing away from us, we thought it was dark. But all parts of the moon are lit the equal amount of time. There's even on a Star Trek episode, I think you mentioned earlier, Judy, that someone said if they lived on the moon, they'd see the sunrise once a month. But the best thing for the naming of the dark side of the moon would be the far side of the moon. Or some even like to name it the shy side of the moon, because it's always facing away from us. It doesn't want to be seen by us.
Yes. And can we explain libration? No, we're not going to get into libration tonight. And yes, libations are more fun. Perseus is correct.
Yeah.
Yeah.
So I believe that's sadly all the time we have tonight. Thank you all so much for joining us for this program.
Mhm.
If you want to see this live stream, will be saved here onto our YouTube channel, and you can see past live streams on our YouTube channel as well. We also have had some other ones about the moon, some about galaxies, some about the sun. We have a very nice array of them.
Oh, go ahead. Keep talking.
I was just going to say, if you want to learn more about the programs we do here at the Visitor Center, visit our website, McDonaldObservatory.org. We do have daytime programs such as tours to the telescopes, so the viewing programs, star party programs at night. We do highly recommend to make reservations because they do sell out fast. And also, if you want to become a friend of the observatory, visit our gift shop online or in person, and also check out some more science stuff through Stardate.
Mm-hmm. And come visit us because we love it when people come to see us.
Yeah.
Well, thank you all. This has been fun. Come back again. Bye.
Bye.